Okay, problem H, work from home. This was, I believe, the second easiest problem in the competition for 2020. The trick to it is that you have to do the unit conversions correctly. Okay, so if we start out with reading the description, we immediately note that she is expensing computer electrical usage, and that also corresponds to our output, which is the number of dollars that she should expense, that Alice should expense. So at this point, I'm immediately thinking, okay, we're outputting a single integer, it's dollars, so I must be calculating some sort of cost here. Now, where do I get the cost from? Well, this is when I would start looking at the inputs that I get, and I notice that there's an integer, another integer, and another integer, and it also says that they're on different lines. So the first line, the second line, and the final line. So there's 3 lines, 3 integers. What do they represent? Well, the first one represents the number of watts that the computer is using. The second line of input is the number of minutes that the computer is being used, and then C is the cost of a single kilowatt hour of electricity as measured in cents. So now I look down at the output and see that we are supposed to round up, and we need to output dollars. Now, none of these are dollars, this is all in cents, and this is in kilowatt hours rather than watt minutes. So we're going to have to do some unit conversions. The first thing to do, though, is to read in the input. So let me open up a Python file, and we're going to read in the inputs W. We have to be careful to make sure to convert the input to the correct type, and we have W, M, and then C. M and C. Okay, so now let's convert it to units that we can deal with. The first one we need to convert to kilowatt hours, or kilowatts from watts, and that's just going to be kilowatts equals watts over 1000. And we want to use floating point division so that we have fractions. Then we have M, which needs to go to hours, and 1 hour is minutes divided by 60. And I'm just going to annotate the units here. So this is in watts, this here is in minutes, this here is in cents per kilowatt hour. So let me kind of expand that out. And this one is kilowatts. This one is obviously hours. And what we can see here is that we have a cents per kilowatt hours. Let's try and convert that to dollars per kilowatt hours. And that's just going to be C over 100 because there are 100 cents per dollar. Dollars per kilowatt times hour. Okay, so now to get dollars, if we multiply all these 3 numbers together, the kilowatts will cancel, the hours will cancel, and we will be left with dollars. Okay, so total equals kilowatts times hours times dollars per kilowatt hour. Now, we have to go back to our problem description, and we notice that we always round up to the nearest dollar. So this is different than normal rounding. We never round down, we only round up. So that's also known as a ceiling. We take whatever fraction it is and then just always go up. So even if it's 1.00001, that would round up to $2. There's a function in Python called ceil, which stands for ceiling, and it's in the math library. And when you take the ceiling of a number, it will do exactly that. It'll always round up. So let's seal our total, and then we can print it. Okay, let's try with the sample input. So I'll run Python workfromhome.py and copy in this sample input. We're expecting that it'll output 16, which it does. So that's good. Always test on at least the sample inputs. And we're getting 24. That's good. And now let's just make sure that it makes sense to us and try our own input. Let's just say that watts is going to be 1000. Our minutes is going to be 60. So this will basically turn kilowatts into, we're using 1 kilowatt, and we are using exactly 1 hour. And then let's just say that it is 100 cents per kilowatt hour. So 100. So what do we expect? We should expect that this is 1, which it is. Now what if the price is just a little bit more? Let's just say it was 101. So 1000, 60, and 101. In this case, we should expect that since D is going to be a little bit more than $1 per kilowatt hour, we should expect that our total price is going to round up to $2, even though the price is $1.01. And that's exactly what happens here. At this point, I think we're pretty confident in the answer, and we can go ahead and submit this just to make sure that we did it right. And as you can see, it's running. So far, so good. In competition, you wouldn't be able to see which test cases are failing, but this is not in competition. This is after the competition, and we can see that, in fact, we got the correct answer.